Hello, welcome to Super 20 of Engineering Mechanics. How are you all doing? Okay, so in this class we are going to solve 20 amazing questions of engineering mechanics. You can watch this lecture. Anyone who has engineering mechanics in their GATE syllabus, GATE mechanical, GATE XC, GATE PI, GATE mining. Good afternoon, good afternoon. And let me tell you, we are going to solve questions from all different chapters of engineering mechanics. There will be questions from statics, there will be questions from kinematics, there will be questions from kinetics, and we are going to solve variety of questions. My aim will be have 20 amazing questions for your perfect revision of engineering mechanics. This is my Telegram group. If you have not joined this group till now, search this name in your Telegram or just scan this QR code, join this group. You are going to get the PDF of this class in this group. You are also going to get the PDF in our GATE Wallah app or Physics Wallah app. So download the app, register, you will find a fresh batch, a free batch for GATE, and there you will get the PDF. Okay, good afternoon, good afternoon, good afternoon. So this is your Maha revision schedule, and we have done the Maha revision till engineering mechanics. So only theory of machines aptitude is left. So tomorrow at 4 p.m. Vishwajit sir is going to take the Maha revision of theory of machines. Don't forget to join. And today at 7 p.m. we have Maha Abhyas of engineering mechanics. So we are going to solve another amazing set of problems in this Maha Abhyas at 7 p.m. The questions will be completely different from this session. Okay, so these will be additional questions. Okay, this is your Super 20 schedule. This is your Maha Abhyas schedule. Both of these sessions are important because we are going to solve different problems in both these. Super 20 problems will be different. Maha Abhyas problems will be okay. Chalo. So I hope you guys are ready because we are going to start with the first question for today. And this is an interesting question, a simple question to start with. The motion of a particle is defined by the relation x equals to 2t cube minus 50 square plus 24t plus 4, where x is expressed in meters and seconds. Determine the time when the acceleration is. Good afternoon. Good afternoon. Quickly give me the answer. This is a simple question because I wanted to start with a simple question. Slowly we are going to the difficulty level. Okay. Thank you so much, Debu. So you have the relation of position with time. You need to find the time when the acceleration, and we have got our first answer from Anubhav. Second answer from Divya. Very good. Ashish, very good. Rohan, very good. Rishabh, very good, very good. Excellent, excellent. So we have x equals to 2t cube minus 15t square plus 24t plus 4. We know that v will be equal to dx by dt. So it will become 6t square minus 30t plus 24. Then acceleration will be d by dt. So it is going to be 12t minus 30. So we got the relation of acceleration time. So when acceleration will be 0, 12t minus 30. So t will be equal to 2.5 seconds. This was a simple question. Yes, everyone got the correct answer. Very good, very good. Chalo. So we started with a positive solution. Let's begin. Let's move on to the next question. Solid ball of mass 10 kg subjected to forces as shown in figure. Another simple question. The magnitude of acceleration is. So particle is subjected to two different forces acting in two different directions. We need to find the magnitude of the acceleration. How will you find the magnitude of acceleration? See, you need to first find the resultant of these forces, because we have two different forces, right? We need to first find the resultant. How will you find the resultant? You'll have to first find the net force in x direction and net force in y direction. What will be the net force in x direction? It will be 100 minus 100 cos 45. What is 100 minus 100 cos 45? It is 29.29 ton. Then summation of Fy will be equal to 100 sine 45. What is 100 sine 45? It is 70.71 Newton. So the resultant will be root over 29.29 square plus 70.71 square. How much is this? 76.54 Newton. So now what we have done, we have found a single force acting on the body, right? Once you got the single force, you can apply this equation F equal to ma, or rather I should write R equal to ma. So this 76.54 is equal to 10a. Yes, 10 kg mass, na? So from here, A will be equal to 7.65 meter per second square. Is this what we are getting? Very good, Divya. Very good, Anubhav. Very good. Excellent. 7.65 meter per second square. So this was a simple question, but still a few of you got incorrect answer because of lack of clear concept. You know this equation F equal to ma, Newton's second law. But here F should be equal to the force, right? Okay, you are considering the weight of the ball also. But here it is not meant that you need to consider the weight. So we will consider only the forces acting on the body, the particle. Because the free body diagram is already given. So we have neglected the weight of the particle. Chalo. So this was an ambiguous question, because if you consider the weight, the answer will be different. But here the free body diagram of the body particle is given, so we have neglected the weight. Okay. Chalo. Moving on to the next question, and this is from truss. The force in the member PR for the truss shown is. What will be the force in this member PR? Yes, actually the weight of the particle, in which direction it will be acting, it is not mentioned, because it might be a top view of the particle, it might be the front view of the particle. Don't know that. So we will assume that the weight of the particle is already included in this diagram, and by assuming that, we have solved the problem. Okay. The force in the member PR for the truss shown is. What will be the force in the member PR? You can apply method of joints, you can apply method of sections. Which method are you going to apply? I think most of you will be applying method of sections, right? So if I draw the free body diagram, there will be one reaction here, there will be two reactions here. Okay. Now we can take a section like this. Okay, and then we can consider the top part. So if I consider the top part, what we are going to get? This is FPR, right? We need to find this force, and these two forces, these other two unknown forces, are intersecting at this joint. Which joint is this? Q joint, right? So if I take moment at Q, moment of these two forces will be gone, right? Moment at Q. So FPR multiplied by 4. This is anti-clockwise. Moment of this 10 kilonewton will also be anti-clockwise. So 10 multiplied by 6 equal to 0. So FPR will be minus 15 kilonewton. I am getting a negative answer, means my assumption is wrong. I assumed this force to be tensile. I am getting a negative answer, means must be compressive. So what is the answer? 15 kilonewton compressive. D is the correct answer. Yes, D is the correct answer. 15 kilonewton compressive. Very good. Excellent. Moving on to the next question. How are you guys finding these questions? Some of you might be thinking, why so easy questions? The questions, easy or difficult, should be relevant. In GATE also you will not find all 100% questions very difficult, right? You will find some easy questions, some moderately difficult, some very difficult. Here also you will find those types of problems. In the figure shown, the friction coefficient of the block and the inclined plane is 0.2, and the pulleys are weightless. Weight of the block is 10 Newton. Minimum force P that is needed to slide the block up the inclined plane is. Friction coefficient between block and inclined plane is 0.2. There is no mention of friction in pulley. So we will assume that the pulleys are frictionless. Okay. We need to find minimum force P that is required to slide the block up the inclined plane. Now you can see that we are applying force P here, but how much force will be developed here, that you will have to calculate first. Okay. So if you apply a force P here, there will be tension here, tension here, right? What will be the force here? If this is P, it will be P by 2, P by 2. If this is P by 2, P by 4, by 4. If this is P by 4, this is by 8, by 8. So how much will be here? By 8, na? Yes. P by 8 plus P by 8 is P by 4. P by 4 plus P by 4 is P by 2. P by 2 plus P by 2 is P. This calculation is clear to everyone, right? So here in this thread or rope, we are getting only P by 8 force. Now we draw the free body diagram of the block, which is inclined at 45 degree, and mu is 0.2. Okay, so we will assume the block is on the verge of moving upwards, right? We want to move this block upward. So draw the free body diagram. We will resolve the forces like this. Here we are getting a force P by 8, and we are assuming block is just about to move up. The friction force will be acting down. What is the weight of the block? 10 Newton. This is 10 cos 45. This is 10 sin 45. This is by 8. This is n1 and this is 0.2 n1. Let's say this is your x-axis, this is your y-axis. So now apply summation of fx, summation of y, get the value of p. You have already got the value of p, 7 point something. Okay, let me check. Please check my calculations because you all know how accurate my calculations are. Those of you who have been watching my lectures, you guys know that I tend to make a lot of silly mistakes. What can I do? So human being, right? I am allowed a few mistakes in calculation set. Summation of fx equals to 0. So p by 8 will be equal to 10 sin 45 plus 0.2 n1 is 10 cos 45. From here you will get the value of p. So 10 sin 45 plus 2 cos 45 multiplied by 8, 67.8. Done. Excellent everyone. Very good. Very good. Vibhu, Ashish, Anubhav, Saurabh, Arya, Rohan, Shivam. Very good. Divya, very good. Swastik, Madhu, very good. Very good. 67.88. Done. Done. Okay. Moving on to the next question, and this is a basic one. A force F equal to 3j minus 6k passes through the point A equal to 4i minus 2j minus 9k. So this is the position, sorry, this is the point at which, this is the point through which force is passing. Moment of F about the point I minus 7k is. Okay, we've been saying keep practicing. I have been practicing for the past 15 years, but still. You guys remember how do we find the moment of a force using vector calculation? Let me show you. The line of action of the force, and this is the point at which we want to find the moment. Let's say this is point O. What do? We consider any one point on this line of action. Let's say we are considering point A. So this is the position vector R. So you need to first find this position vector R. So how do you find the position vector R? Head minus tail, not tail minus head. It is always head minus tail. Na? So R will be equal to, what is the head? It is the point through which force is passing, 4i minus 2j minus 9k. Minus, what is the tail? It is the point at which we want to calculate the moment, 6i minus 7k. Let me tell you, you might get a question based on vector. Okay, so you compare. So is this the position vector you are getting? Minus 2i, minus 2j, minus 2. Yes. Now we need to find the moment vector. Moment vector is r vector cross f vector. You all know how to find the cross product of two vectors. So r vector is minus 2, minus 2, minus 2. And what is the force vector? 3j minus 6k. 0, 3, minus 6. What will be the moment vector? I into 12 plus 6, 18i minus j, 12, 0. So minus 12j, then plus k, minus 6. So minus 6k, right? So if I take 6 common, it will become 3i minus j minus k. Which one is the answer? 3i minus 2j minus A is the correct answer. Very good, excellent everyone. Divya, Anubhav, Shivam, Rohan, very good. Madhu, Ashish, Swastik, Vibhu, very good. 6 into 3i minus 2j minus. Okay. So this is based on the vector calculation of moment, a very important concept. Moving on to the next question. This is based on the calculation of moment of inertia. The figure shows a rectangle with circular hole. Moment of inertia of this area about the base is. It's a rectangle with a circular hole. We need to find moment of inertia about the base. What is the moment of inertia of rectangle about its base? You guys know? Let's say this is your x-axis. So you can directly find moment of inertia of rectangle about this x-axis. What is the moment of inertia of rectangle about base? It is bh cube by 3. Yes, bh cube by 12 about the centroidal axis. About the base, bh cube by 3. If you don't remember, don't worry. You can apply parallel axis theorem, right? So bh cube by 3. It will be 200 into 300 cube by 3. This is the moment of inertia of rectangle. Now we have to subtract moment of inertia of circle. Now the centroid of the circle is here, right? From here to here, what will be the distance? 200 mm. So you will use parallel axis theorem. Moment of inertia of circle about centroidal axis 5 by 64 e to the power 4 plus area 5 by 4 into square multiplied by distance square. So 200 square. You are going to get moment of inertia about x-axis. How much is this? It will be m to the power 4. Huh? So 1068291164 mm to the power 4. But they are asking to find moment of inertia in centimeter to the power 4. So you will multiply 10 to the power minus 4, right? So 106829.12 centimeter to the power 4, rounding off to 2 decimal places. 106829.12. Yes, very good, Rohan, Anubhav, very good. Ashish, your answer is a little off. 106829.12 is the exact answer. 106829.1. Let me explain the calculation again. The moment of inertia of rectangle about its base is bh cube by 3. About its centroidal axis, bh cube by 12. So if you don't remember this formula directly, you can apply parallel axis theorem for rectangle also. Then for circle, moment of inertia about its centroidal axis is 5 by 64 d to the power 4 plus area 5 by 4 d square multiplied by this distance square 200 square. Got moment of inertia of the shaded area. Yes, very good. Moving on to the next question. Now this is from kinetics of particles. So already I have solved problems from 5 different chapters. We have solved problems from basic concepts, equilibrium, then we got problem from friction, truss, then moment of inertia, and now this one is from kinetics of particles, right? A block A of mass 20 kg is connected to another block of mass 12 kg by a massless and inextensible string passing over a friction B. Coefficient of kinetic friction between B and surface is 0.3. If block A is released from rest, tension developed in the string will be. You need to find the tension developed in the string. A and B are connected by the string passing over friction. Means tension on both sides same. If it is released from rest, what will be the tension? So we will use Newton's method to solve this problem, Newton's second law. Yes, we can use any method. Let's use the Newton's second law. So we will draw the free body diagram of both the blocks separately. Okay. Block A. Obviously, it will fall downward, right? It will move downward the direction of motion. Let's say the acceleration is A. What will be the forces acting on this? T will be the tension and weight will be 200 Newton. So if I apply Newton's second law, summation of F equal to ma, A is downward. So downward force is positive, upward force is negative. So from here, A will be equal to 20 minus by 20. Yes. Sorry, not 20. 10 minus T by 20. So this is the relation between acceleration and tension. Now we'll draw the FBD of block B. Block B is subjected to tension, then weight of block B, normal force and friction force opposite to the motion is going to move towards left side, right? Acceleration will be same A, tension will be same T. Weight of block B is 12 kg, 120 Newton. This is NB, and what is mu? 0.3. So 0.3 N. Now here summation of Fy will be 0 because in y direction it is m. So NB will be 120 Newton, but summation of Fx will be equal to ma. So in direction of A, T is positive minus 0.120 equal to M is how much? 12, and what is A? A is 10 minus T by 20. So this will become T minus 30 equals to 120 minus 12T by 20. By solving this, we'll find the value of T. So 120 plus 36 divided by 1 plus 12 by 20. So I am getting 97.5 Newton. Are you guys getting the same answer? 97.5 Newton. Very good, very good, excellent. Saurabh, Divya, Pastik, Ashish, and Kundan, Shivam, Anubhav. Very good. 97.5 Newton. The tension in the string is 97.5 Newton. You can find the acceleration also from this equation, right? Chalo. Moving on to the next question, and this is from wedges. Application of friction. A rock block of mass 100 kg is to be lifted by a horizontal force P as shown in figure. Smooth rollers are placed between the wedges. See, These are the wedges. Wedge number A, wedge number B. Coefficient of static friction between wedge A and surface C and between wedge B and surface D is 0.3. Ignoring the weight of the wedges and friction between the roller and the wedges, minimum force P kg required to lift the block. So they are asking you to find the force P kg. All the forces have to be taken in kg. Okay, you don't need to convert them in Newton. Consider the forces in kg. So you have to lift this rock by applying force P to this wedge. So we will have to draw multiple FBD here. You will have to draw the FBD of this and this separately. Yes or no? Draw this FBD of this wedge and find the normal reaction here. Then draw the FBD of this wedge and find the force P. Let's draw the FBD of this wedge. Wedge B. Looks like this. Yes. What are the forces acting here? The weight of the rock 100 kg. Then there will be some normal reaction from here. There will be some normal reaction from here. Now it is being lifted. The normal friction force will be acting downward, right? This edge. What are the this? This is 100 kg. Okay. So let me call this N1. Let me call this N2. Q here is 0.3 N2. Okay. What is the angle between N1 and vertical? So the surface is making 10 degree with horizontal. So N1 will be making 10 degree with vertical. Yes. So now you can find the value of N1 from here. How you can find the value of N1? From summation of Fx and summation of Fy. So summation of Fx equals to 0 will N1 sine 10 degree equal to N2, right? N1 sine 10 degree equal to N2. Then from summation of Fy equal to N1 cos 10 degree equal to 100 plus 0.2. So N1 cos 10 degree equal to 100 plus 0.3 to N1 sine 10 degree. So from here you will get the value of N1. How much is this? 100 by cos 10 minus 0.3 sine 10. I am getting 107.5 Newton. 107.21 Newton. Okay. Now we will draw the FBD of this wedge A. The wedge A looks like this. The N1 will be same between A and B. The normal reaction will be same. There will be a force here and friction force. N1 which is 107.21. This is P. Let me call this N3 and 0.3. N1 is at 10 degree from vertical. So again we will apply summation of Fy equal to 0. So N3 will be equal to 107.21 cos 10 degree. Then from summation of Fx equal to P will be equal to 107.21 sin 10 plus 0. So P will be equal to how much? 107.21. Sorry, this is kg na. I have written Newton. Sorry. $50.29 kg. Are you guys getting this answer? 50.29 kg. Yes, almost 50.3 kg. Very good, very good, very good. 50.29. Now let me tell you, this is from GATE PI. The previous year question of GATE PI. Okay, so if you are wondering whether you might get this lengthy question in GATE, yes, this is from GATE, from other branch. So you might get a question like this in your exam. Okay, very good. 50.29 kg. Chalo, moving on to the next question. A uniform bar of 10 kg and length 6 meters hangs from a friction. It is released from rest in the horizontal position. Angular velocity when the bar is rotated 45 degree from the horizontal position. Means in this position the bar is at rest. When it will rotate and come at 45 degree, what will be the angular velocity of the bar? Achha, tell me one thing, is there any issue with the audio today? Yesterday we were facing a little. I hope it is clear now. No issue today. One guy is saying yes, another guy is saying so. How do I know what you guys are trying to say? No issue? Yes issue. No issue, na? Acha, still there is an issue. But is it manageable? Is it manageable? Okay. So I'll get it checked, but not possible today. Have back-to-back 2 classes. So I'll get it checked tomorrow. Chalo. Now here we can use work energy method, or better we can use conservation of energy, right? Can we use conservation of energy? Initially, this was the center of gravity. After rotation, it will come here. So, what will be this distance? Length is 6 meters. Na? This is 3 meters and this angle is 45. This is 3 sine 45 degree. Okay. Let's say that this is the initial position A, this is the final position B. So, can we apply conservation of energy here? Why? Because there is no loss of energy. Huh? There is no friction or anything. So, we can apply conservation of energy. So, energy at A is equal to energy at B. So, let's say that in this position, the potential energy is 0. So, in this position, you will have some potential energy because it is above the second position. In the first position, there is no kinetic energy, right? Let's say this is point O, center of rotation. So, in the first position, you only have potential energy. In the second position, you will have kinetic energy, half I omega square, but I must be about center of rotation, right? So, what is the mass? 10 kg, length 6 meters, G 10 meter per second. So, 10 into 10 into 3 sine 45. Mass moment of inertia about O will be ml square by 3. So, from here you will get omega. .88 radian per second. Is this the answer? 1.88. Very good, yaar. Very good. Divya, very good. Anubhav. 1.88 radian per second. Excellent. One 1.88 radian per second is the angular velocity of the rod. Yes. Shall we move on to the next question? Now, this is from friction. A square block of side 1 meter and mass 10 kg is resting on horizontal surface. Coefficient of static friction is 0.75. A horizontal force P acts on the block as shown in figure. Force P is gradually increased from 0 until the block either slides or topples. Maximum value of H for which block slides without toppling is. Draw the FBD. We will assume that it is on the verge of toppling, right? It's a square block of side 1 meter. We are applying force at some height. Weight is acting at the center. We are assuming it is on the verge of being toppled. P, let's say this is an A. Let's say this point is A. What is coefficient of friction? 0.75. Is the weight 100 Newton. What is this distance from center? 0.5 meter, right? 0.5 meter, and this is height h. So from summation of Fy equal to 0, Na will be 100 Newton. From summation of Fx equal to 0, E will be 0.75 A, means 75 Newton. So if I take moment at A, then P into H, 75 into H will be 100 into 0.5. So H will be 50 by 75, means 0.67 meters. Is this the correct answer? Very good. 0.67 meters. If the height is more than this, it is going to topple, right? Up to this point, the block will slide. After this, the block will topple. Moving on. If all the pulleys are massless and frictionless, minimum force P required to hold the weight of 100 Newton is. Another problem related to pulleys, this weight is 100 ton. Okay. This is a single rope passing from here, 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 and this is another rope passing from here to here. In the yellow rope, the tension is P. So this is P, this P. But if this is P, this is P, then this is by 2, this P by 2. Sorry, my mistake. Not by 2, 2P. P, 2P. So in the yellow rope, tension is P, and in the green rope, tension is 2P. Yes. So here P plus 2, 100, na? 4P will be 100, so P will be 25 Newton. Very good, Vibhu, Arya, Shivam, Ashish, Rohan, Divya. Very good, Rishabh, Kundan, Anubhav. Very good, very good. 25 Newton. The yellow rope tension is, but in this rope tension is 2. So if you look at this one, 100 Newton acting here and 2 acting here. So P 25 Newton. Very good. Moving on, the next problem. What happened? Oh, hanged. Okay. A spherical rigid ball of mass 10 kg is moving with a speed of 2 meters per second in the direction shown. Ball collides with a rigid frictionless wall and rebounds at an angle alpha with a speed v. Coefficient of restitution is 0.9. Angle alpha is. Aditya is asking MRV, which is the Research Valley, in which department I was working? I was working in CAE department. Particularly structure. CAE department is also further divided. There is a CAE department for automobile, then there is a CAE department for farm. But in automobile, it is further divided. There is a CAE department for structure, department for engine. I was working in CAE structure automobile. We need to find this angle alpha. How do we find it? See, this is a problem related to oblique collision, right? This is the line of impact, which will be normal to the surface. See, when a body is colliding with a surface, then the forces act normal to the surface. So this is line of impact, y direction. So the velocities in y direction will change, but velocities in x direction will not change, right? So let's say this is the initial velocity, this is the final velocity. So final velocity in x will be same as initial velocity x. Vx will be equal to ux, which is 2 cos 60. But final velocity in y direction will change. So Vy will be E times of Uy. Very easy. So E is 0.9, right? And Uy is 2 sin 60. So it will be 1.8 sin 60. Now alpha, see, this is your final velocity. If you take the components, this is Vx, this is Vy, your angle alpha, right? So alpha will be tan inverse of y by Vx. So tan inverse of 1.8 sin 60 by 2 cos 60. What is alpha? .32 degrees. This is the angle after impact. Initially, it was 60 degree. After impact, this angle will become 57.32 degree. Very good, excellent everyone. Very good. Another question from kinetics of particles. 2 kg block moving with a speed of 4 meter per second hits a spring of 8 Newton per meter as shown in figure. Coefficient of friction between the block and the surface is 0.5. Spring is initially undeformed. Maximum compression due to impact is. Solve this. So just before hitting the spring, the velocity is 4 meter per second. After hitting the spring as it gets compressed, the block will start moving further. So it will give its energy to spring, right? So here maximum compression of spring will at the point when this block will come to rest. It will give all its energy to spring and it will come to rest, right? So in the final position, when the spring is compressed to maximum, the block will come to rest. So let's say x is the distance by which spring is compressed. So x will be the distance by which block has moved. If you draw the free body diagram of the block, this is weight, normal reaction, friction force. Block is moving towards the right side, right? What is the weight of the block? 20 Newton. Let me call this N1. Q is 0.5 N1. So summation of F in the direction of motion is minus 0.5 N1, means minus 0.5 into 20 minus 10 Newton. The friction force opposite to the motion. So here we will apply this equation, right? Summation of Fx multiplied by x equal to half m t square minus u square plus half k x2 square minus x1. So what is the net force in the direction of motion? Minus 10. Has moved by x distance. Mass of the block is 2 kg. Final velocity 0. Initial velocity 4 meter per second. Stiffness of the spring is how much? Stiffness of the spring is 8 Newton per meter. X2 means final deformation of spring, which is x. X1 means initial deformation. So you will get a quadratic equation in terms of x. 4x square plus 10x minus 6 equal to 0. If you solve this, you will get two values of x. One is 1.11, another is minus 3.61. So we are going to go with the positive value 1.11 meters. Very good, Arya. Very good. Very good. Very good. 1.11 meters. Yes. If there is no friction, you can apply conservation of energy. So the entire energy of the block will be gone to the spring. So half mv square will be equal to half kx square. That will be a very simple problem, right? Let's move on. Now this is from kinetics of rigid bodies, your favorite topic. A rope is wrapped around a cylinder of radius r and mass m. Knowing that cylinder is released from rest, velocity of the center of cylinder after it has moved downward a distance 6 meters is. It is not mentioned in the problem, but here you have to assume there is no slip. When it will be unwrapped, there will be no slip this cylinder and the row. Then only you are going to solve the problem. I told you, while solving this type of problems, assume that it is rolling without slipping on this surface. The cylinder is rolling without slipping on this surface. Similar problem has been there in gate mechanical long time back. Okay, similar question. So you can assume that this cylinder is rolling without slipping on this surface. So which one will be the center of rotation? This is not the center of rotation. This point will be the center of rotation. So you can draw the free body diagram of the cylinder. This is point. This is point O. O is center of rotation. Is this clear to everyone? This is the weight and this is the tension. The row. We know that in case of rolling without slipping, the point of contact is a point of zero velocity, center of rotation. So there is no work done at this point. There will be no work done by the force T. Only work done by this weight. What is the weight? mg. So here work done equal to change in kinetic energy. Work done equal to change in kinetic energy. So mg multiplied by vertical displacement of g equal to half I-O square minus omega square. Is this clear to everyone? Here, how much is YG? 6 meters. It is mentioned. What will be the mass moment of inertia about point O? It's a cylinder. So mass moment of inertia about point G is mr square by 2 and mass moment of inertia about point O is 3 mr square by 2. Right? So this m and m will be cancelled. Right? G is 10 meter per second. Huh? So from here, omega square r square, or you can find omega r. Na? How much is omega r? M and m will be cancelled. So 10 into 6 into 4 by 3 root over answer 8.94 meter per second. So velocity of G is omega r 8.94 meter per second. This is the answer. Very good guys, very good. Anubhav, Rohan, Arya, Divya, very good. 8.94 meter per second. This is the center of rotation. So linear velocity of G will be omega into distance from here to here, which is r. So omega r. Interesting question. All my questions are interesting, right? A particle is undergoing pure translational motion and acceleration is given by A equal to 2t square plus 4t minus 10. Particle was initially at rest. Velocity at t equal to 5 seconds. Find the velocity at t equal to 5. Initial velocity is 0. How do we find velocity from equation of acceleration? A is equal to dv by dt and it is given as 2t square plus 4t minus 10. So how do we find velocity? dv will be 2t square plus 4t minus 10. Integrate this. What is the velocity at t equal to 0? 0. At t equal to 5, need to find velocity. So this will become v equal to 2t cube by 3 plus 4t square by 2 minus 10t, limit 0 to 5. What is v? (83.33 meter per second). This is the velocity. Very good, guys. Very good. 83.33 meter per second. Very good. Moving on, the next problem. A horizontal force P applied on a cylinder of mass and using a cord wrapped around its periphery as shown in figure. Assuming there is no slipping, acceleration of the center of mass is. So here we need to find acceleration. Acceleration of center of mass. So which equation we are going to use? We will use Newton's second law. Yes, this is rolling without slipping. In case of rolling without slipping, the point of contact is the center of rotation, right? This is G, this is O. O is center of rotation. This is mg, this is n, f, p. So we need to find the acceleration of the center of mass g. It will be alpha into r, right? We can use this equation. Net moment about O equal to I O alpha. Why we are taking moment about O? We can only take moment about G or O. At point O, there is a friction force which is not known. So we have taken moment at O. So the moment of N, F, Mg all will be gone. Moment of P will be 2r. Mass moment of inertia about O. So it is a cylinder. So it will be 3mr square by 2 alpha. So this alpha into r, from here alpha into r will be how much? 4p by m. So acceleration of g is 4p by 3m. Yes, is the correct answer. C is the correct answer. 4p by 3m. See, all the questions we are solving, you can see, are from different chapters, different topics, different concepts, and all these questions are very relevant. You will find similar questions all the gate exams, whether it is mechanical or XC or some other branch. Similar questions, I can definitely say you will find these questions in your gate 2026 exams also. Similar questions. Okay. A ball of mass 5 kg moving with velocity 4 meter per second collides centrally with another ball of mass 2 kg moving with 10 meter per second in opposite direction. Coefficient of restitution is 0.8. Velocity of the 3 kg ball, sorry, not 3 kg, 2 kg ball. There is no 3 kg ball. Velocity of the 2 kg ball after collision is. This is a simple problem of direct collision. Na? We have solved problem of oblique collision. This is direct collision. So we have a problem like this. There is a ball of mass 5 kg moving with 4 meter per second. Another ball of mass 2 kg moving with 2 meter per second. In opposite direction. Okay. After collision, we need to find their final velocity. Okay. $10 meters. Okay. Let's say this ball number 1, ball number 2. So we need to find V2. How do we find V2? We have two equations. One is M1 U1 plus M2 U2 equal to M1 V1 plus M2 V2. So 5 into 4 minus 2 into 10 equal to 5 V1 plus 2 V2. Okay. 5 V1 plus 2 V2 will be 20 minus 20, 0. So V1 will be minus 0.4 V2, right? Then E equal to V2 minus V1 by U1 minus 2. So E is 0.8. So V2 minus V1 by 1 is 4 and U2 is minus 10. 4 minus minus plus. So V2 minus V1, which is minus of 0.4 V2, equal to, this will be 14 into 0.8, which is 11.2. So V2 will be 8 meter per second. Yes, very good, yaar, very good. 8 meter per second, and it will be in the direction of the first ball. Initial velocity of the first ball, whichever is the direction, that will be the final direction of this ball after collision, right? Moving on to the next problem, this is an interesting one. The radius of gyration of the 20 kg pulley about G is 300 mm. Angular acceleration of the pulley is. We need to find angular acceleration alpha. Radius of gyration is 0.3 meters. You can see on one side we are applying a force of 600 Newton. On another side there is a weight of 400 Newton. In which direction the pulley is going to move? This is 600, this is 400. So obviously the pulley will move like this. Yes or no? If you draw the free body diagram, there will be weight, there will be reactions at the hinge, but we don't need to consider all of them because we are going to take moment at this weight is 400 Newton. We can use this equation, summation of mg equal to ig alpha. If I take moment at G, moment of weight and reactions will be 0. You will get moment of this and this. But here, you have to consider the moment in the direction of alpha to be positive, opposite to alpha negative. Okay. So, moment of 600 will be positive, moment of 400 will be negative. So, 600 into 0.4 minus 400 into 0.4. I will be mk square. Mr square by 2 no, because radius of gyration is given. So we will use mk square. M is 20 kg, k is 0.3. But here you have to consider the mass moment of inertia of this 40 kg block also, right? So what will be the mass moment of inertia of 40 kg block? You can consider it to be a point mass. So 40 to 0.4 square. Distance of this point mass from G is 0.4. So from here you will get alpha. Okay. I hope you guys have considered the mass moment of inertia of the block. 9.76 radian per second square. Yes? Are you guys getting this? So all of you, Shivam, Vibhu, Kundan, Rohan, got the wrong answer because you have not considered the mass moment of inertia of this block. See, if we are applying a pure force, this doesn't have any inertia, but mass have inertia, right? This is a mass, so it will have inertia. You have to consider the mass moment of inertia about this point. For this mass also, if the shape and size of this block is not given, we will assume this to be a point mass. It's a point mass. So what will be the distance of this point mass from G? 0.4 meter, perpendicular distance. Okay. So m into distance square will be the mass moment of inertia of this 40 block. Is this clear? Is this clear? Moving on to the next question. A circular disc of diameter 4 meter rolls without slipping at a speed of 2 radian per second and angular acceleration of 8 radian per second square at the instant shown in figure. Magnitude of acceleration of P at this instant is. So at this particular instant, we know omega, we know alpha, we need to find linear acceleration of P. How do we find linear acceleration? I have told you, in order to solve this problem, you break this into pure translation plus pure rotation. You guys remember? I told you, whenever you have to find the acceleration in rolling without slipping, break it into translation plus rotation. Okay. Translation plus rotation. In case of translation, every particle has same acceleration alpha into r. Center has same acceleration alpha into r. Center is pure translation. Center is under pure translation and the acceleration is alpha into r. So every particle will have same acceleration alpha into r. Okay. So here this acceleration will be alpha into. But in case of pure rotation, we will assume it is under pure rotational motion about point G. So in that case, what will be the direction of, what will be the acceleration? It will have two accelerations, an, which will be omega square into r, and at, which will be alpha into r. So now you can find total acceleration. Is this clear? Is this clear? So point P has three acceleration components. Okay, let's say this is point P. It has three acceleration components, alpha into r, then omega square into r, and alpha into r. And these are at 45 degree. Okay. So acceleration of P will be equal to how much? Alpha r plus alpha r cos 45. Let me calculate alpha r and omega r, that it will be easier. What is alpha r? 8. R is 16. Omega square into r. Omega is 2. R is 8. This is 16. This is 16. 8. Now calculate total acceleration. Just find the resultant. So in x direction is 16 plus 16 sin 45 minus 8 cos 45. Sixteen plus 16 cos 45 means 16 by root 2. Huh? Cos 45 is 1 by root 2. Huh? Plus minus 8 by root 2 square. Then y direction minus 6 by root 2 minus 8 by root 2 whole square. So you will get total acceleration of P. .51 meter per second square. This is the acceleration of point P. 27.51. Very good, yeah, very good. 27.51. Clear? What about moment due to inertia on 40 kg block in? Okay, let me clear this problem. See, one student is asking why we haven't considered the moment due to the inertia force, right? See, understand this point. Either you consider the inertia force of this mass or you consider the mass moment of inertia. Don't do it in both. Don't do it both because it will cancel. Understand what I am saying? If you consider the inertia force, what is inertia force? Ma. So this block is moving upward, so inertia force will be acting downward, Ma. Okay. So you will have to take the moment of Ma about point G and that you will write here. But in that case, you don't consider the mass moment of inertia. So either do this or do that, but don't do both. Because both will be cancelled, because both are equal only. The moment of inertia force and the mass moment of inertia, both are equal. Are you getting my point? So either we will consider the moment of the inertia force Ma or we will consider the mass moment of inertia of this. Clear? Chalo. This is also clear to everyone. How to find acceleration in case of rolling without slipping? Pure translation, every particle will have same acceleration alpha into r. In case of pure rotation about g, there is one normal acceleration component towards g, one tangential acceleration. Okay. Now you have to take the resultant of all these components. Okay. Chalo. Moving on to the next question. Now in this case, you have cylinders on both sides. In the last problem, there was only one cylinder, one force. Now you have cylinders on both sides. Let me see how many of you get the correct answer in the first attempt. Two cylinders A and B having weight of 8 kg and 4 kg are attached to the ends of a massless and inextensible cord which passes over 2 kg pulley. Cylinders are released from rest. Their speed at t equal to 5 seconds is. Assume cord does not slip on the pulley and acceleration due to gravity is 10 meter per second square. Cord does not slip on the pulley? Then how the pulley will rotate? this, I think, assume cord does not slip on the, not be written. Assume acceleration due to gravity is, because the pulley will only rotate if the cord is slipping on the pulley, na? If it is not slipping, then how it will rotate? Someone is asking if they only solve test series question and Abhyas based question, will it be? Yeah, see, question is something you have to ask yourself. I have seen a lot of students asking me, will this be enough? Will that be enough? See, for some people, even not solving a single question might be enough. If they have an IQ equal to IQ of Einstein, they don't even need to solve a single question. So how much you have to practice, that you have to decide. I can't tell you that. Okay, I have given you all the resources. How many resources you, that you have to judge yourself. Okay, chalo. So we have a pulley. On both sides of the pulley we have discs, cylinders. There is a bigger cylinder, there is a smaller cylinder, but we have cylinders on both sides. Now, the direction of rotation of pulley will depend upon which cylinder is heavier. So A is heavy, na? A has a mass of 8 kg, B has a mass of 4 kg. So this is heavier, 80 Newton, this is 40 Newton. So obviously, pulley will move in which direction, beta? Obviously, pulley will move clockwise, na? The center of gravity of the pulley, there will be weight of the pulley, there will be reactions, but we don't need to consider them because we will take moment at G. Summation of M about G equal to Ig to alpha. Yes. Now, if I take moment at G, moment of these three forces will be 0. Moment of 80 Newton will be positive because it is clockwise. Alpha is clockwise. So, moment of 80 Newton block will be positive. So, 80 into, what is the distance from center O? 1 meter. Okay. Minus 40 into 1 equal to, what is mass moment of inertia of cylinder, this pulley? It will be mr square by 2. Okay, because radius of gyration is not given. So pulley has a mass of 2 kg, radius 1 meter. So 2 into 1 square by 2. But we have to consider mass moment of inertia of these two blocks also, cylinders also. So 8 kg and 4 kg, na? So 8 into 1 square plus 4 into 1 square. So from here you will get alpha. What is alpha? (40 by 13) radian per second square. Yes. So acceleration of cylinders will be alpha into r, right? Acceleration of cylinders will be alpha into r. So 40 by 13 1 means 40 by 13 meter per second square. And this acceleration will be constant. So we can use this equation for cylinders. V equal to u plus at. Initial velocity is 0 and time is 5 seconds. So what is the final velocity of cylinders? 15.38 meter per second. Both cylinders will have 15.38 meter per second velocity. the direction will be different. This cylinder will go down, this cylinder will go up, right? But the velocity will be equal, 15.38 meter per second. Yes, the speed will be equal. Speed will be equal, but direction of velocity will be different. This is downward, this is up. 15.38 meter per second. Is this clear to everyone? Is this clear to everyone? Okay. We have solved the amazing questions today from 20 different concepts, different types of problems from all chapters, right? So I hope you had an amazing revision, but do come at 7 p.m. on our 𝐂𝐤𝐴 ME channel, because we will solve another amazing set of problems there. Okay, at 7 p.m. there is another practice session, Maha Abhyas, different questions. Okay, so you will have another set of amazing problems. Okay, so Telegram group, get the PDF. Tomorrow at 4 p.m. you have the Maha revision of Theory of Machines by Vishwajit sir. So don't forget to watch the Maha revision of Theory of Machines. Okay, chalo. Thank you so much, Subhash. Thank you so much for the appreciation. Much. Okay, so I'll see you guys at 7 p.m. on 𝐂𝐤𝐴 ME channel. Okay, chalo. Thank you. Bye bye. Take care.